The second chapter of AI, a modern approach by Stuart Russell and Peter Norvig, delves into the concept of intelligent agents, which form the basis of understanding AI system. First, what is an agent? The chapter begins by defining an agent as an entity that perceives its environment through sensors and acts upon through actuators. In the context of AI, an agent can be anything from a simple program that solves a mathematical problem to a sophisticated robot navigating through a physical environment. The authors emphasize that the key to designing an intelligent agent lies in understanding how it interacts with its environment and performs actions to achieve its goals. The distinction is made between an agent and its program. An agent is the complete entity that interacts with the environment, whereas a program is the algorithm that detects its behavior. Second, the structure of agents. Russell and Norvig explores the internal structure of agents, focusing on how they process, percept information received from the environment, and generate actions. The chapter introduces a simple model for an agent that follows a perception cycle. It perceives the environment, makes a decision based on the percept, and then performs an action. Agents can be characterized in different ways. First, simple reflex agent. These respond directly to percept without considering history. They follow condition access rules like if X, then do Y. These agents work well in fully observable environment but struggle with partial observability. Second, model-based reflex agent. These uses an internal model of the world to keep track of aspects of the environment that are not directly observed. This allows them to handle partially observable environments by maintaining an internal state. Goal-based agent. In addition to the current state, these agents are driven by goals which provide a basis for choosing among multiple possible actions. Goal helps agents make decisions that lead toward a desired outcome. Third, utility-based agents. These agents assign a utility value to each state and act to maximize the expected utility. This approach helps in cases where there are trade-offs between different goals or action. Fourth, learning agents. Learning agents improve their behavior over time from learning from past experience. They have components like a learning element for improving performance, a performance element for choosing actions, a critic for providing the feedback, a problem generator for suggesting a new experience to learn from. Third, the concept of rationality. The authors introduces the idea of rational agent, which acts to achieve the best possible outcome based on its percepts and knowledge. Rationality is defined in terms of the performance measure that evaluates how well an agent is performing. A rational agent seeks to maximize its performance measure given in the information and computational resource available. Russell and Norvig discuss how rationality can be context dependent. First, perfect rationality involves making the best decision possible, but this is often impractical due to computational limitations and for incomplete information. Second, bounded rationality acknowledges these limitations and focuses on making the best possible decision with those constraints. Fourth, environment for agents. The chapter outlines different types of environment in which agents operate and how the nature of environment influences the design of the agent. First, fully versus partial observable. In a fully observable environment, an agent has access to the complete state of environment through its sensors, making decision making straightforward. In a partial observable environment, the agent must rely on its external state for memory. Second, deterministic or stochastic. In deterministic environment, the next state is completely determined by the current state and action. In stochastic environment, outcomes are uncertain, requiring probabilistic reasoning. Third, episodic versus sequential. In episodic tasks, the agent's experience is divided into episodes and decisions in one episode do not affect future episodes. In a sequential task, current decisions can have long-term effects. Static versus dynamic. A static environment remains unchanged while the agent is deliberating, whereas a dynamic environment changes over time. Discrete versus continuous. A discrete environment has finite set of distinct states and actions, while a continuous environment allows for a range of values and actions. Single agent versus multi-agent. In a single agent environment, there is only one agent acting in the environment. While in a multi-agent environment, multiple agents can interact, cooperate, or compete. These classifications help determine the strategies an agent should use and the challenges it may face. Fifth, agent programs and architectures. Russell and Norvig describe how to implement agents using different architectures, which are frameworks that define the internal structure of an agent program. Key agent programs architecture include table-driven agent. These use a table that maps percepts to actions. This approach is impractical for complex environments due to enormous size of the table needed. Simple reflex agent. As mentioned earlier, these use condition action rules to determine the action based on current percepts. Model based reflex agent. These agents maintain an internal state to keep track of the world, allowing them to handle partially observable environments. Goal based agent. These agents are used goals to choose actions that help achieve a specified outcome. Utility based agent. These agents aim to maximize a utility function which represent the disability of outcome. Learning agent. Capable of learning from experiences, these agents improve over time by adjusting their behavior based on feedback. The choice of agent architecture depends on the nature of the problem being solved and the characteristic of the environment. Now, the conclusion. The second chapter provides a foundational understanding of intelligent agents, which are central to AI. It covers the various types of agents, their decision-making processes, and how they interact with the different environments. The chapter lays the groundwork for designing rational agents, understanding the diversity of environment, and selecting appropriate architectures of AI application. It serves as a critical introduction to more advanced AI topics by establishing the principles that guide agent behavior and rationality. Thank you.